This is A2physics 5 and this is a question about capacitors from June 2006. Number 1. An uncharged capacitor C is connected in series with a resistor R. A battery and a switch is shown in figure 1.1 and this is this figure down beneath. After a time t equals 0, the switch is closed. On figure 1.2, sketch a graph to show the variation of the potential difference VR across resistor R with time t. Now we know initially that the voltage on the capacitor, which is uncharged, isn't 0, but it builds up. So obviously the voltage across the resistor R with time t, initially it's going to have all the voltage, and then as more and more is going to be transferred onto C, then it's going to go down, and less current is going to flow through that as well, of course, and you know that. So whenever the switch is closed, current flows so that it charges up the capacitor. That means that there's current also flowing in the resistor, but that reduces and reduces, and therefore if you use V equals IR there, of course V reduces here as well. So it's going to fall just like the way the current stops flowing exponentially, and something like that there, a curve shape going down. On figure 1.3, this is part 2, sketch a graph to show the variation of the charge QC on the capacitor with the potential difference VC across it. So if you write down the equation, Q is equal to C and VC, so Q is equal to CV, and therefore QC is proportional to VC, so it's going to be a straight line which goes through the origin. Part B, 3 capacitors are connected in series to a 12-volt battery as shown in figure 1.4. The capacitance of one of the capacitors is unknown. This capacitor is labelled C. The capacitors of the other 2 capacitors are marked on the diagram, and there are 4 microfarads and 12 microfarads. The total energy stored in the 3 capacitors is 1.44 by 10 to the minus 4 joules. Calculate the total capacitance of the 3 capacitors in series. And so we're just going to use one of our energy calculations, and we need capacitance and we know voltage, so we're going to use a half CV squared. And the C that we're going to calculate then is the total capacitance. So that's equal to half C times 12 squared, and that's 1.44 by 10 to the minus 4. Just scanning a wee bit. Therefore, C is going to be equal to 2 times 1.44 by 10 to the minus 4 over 12 squared is 144. And that's going to give you an answer of 2. So 2 microfarads is your answer. And then the third part, calculate the capacitance of the unknown capacitor. Now the 3 of them are in series, and therefore we have to do a 1 over fraction sum. So we know the total is 1 over 2, and that's equal to 1 over 4 plus 1 over C plus 1 over 12. So if we change that all into twelfths, 1 over C then is equal to 1 over 2 is 6 twelfths. Take away the quarter is 3 twelfths. Take away the 1 12th is 2 twelfths. Gives you 2 twelfths. And then you have to turn it upside down. So C is equal to 12 over 2, and therefore C is equal to 6 microfarads.